Okay. Our next speaker for this session is Ilan Gitter, and he will talk about confidential transfers for global payments.
All right. Hey, everyone. Thanks to ZKProof and the lovely sound people making me feel like I'm in a 90s boy band. It's fun. Okay, so I'm going to talk about confidential transfers on Solana, what we did, how we're enabling it, what we're actually going to be doing for hopefully some of the largest payment companies in the world. As we've seen on blockchains generally, right, we have everything visible on chain for the most part. The amazing work many of you guys are doing here is to make it so we can actually have private transactions, private information, and be able to do a lot with it. However, there are some problems on Solana that are maybe a little bit unique. We have fairly small transaction sizes, so about 1,000 bytes per transaction. And then on-chain in the accounts themselves, they're also a bit expensive, and you can have up to 10 megs on a particular account. And so when you have these two things, you end up with this constraint that you need to keep things cheap and small, and then also fast, because we do anywhere between 1,200 to 3,600 TPS live on mainnet. And so how do you deal with thousands of transactions per second while also trying to keep things private? So little intro for myself. I lead ecosystem engineering at Solana Foundation. I'm not a cryptographer. I've sort of just been trying to learn as fast as I can for this talk and this event, which has been amazing, and I have had a lot of fun learning and trying to catch up. So unfortunately, the creator of this protocol, Sam Kim, was unable to join, but he did teach me a lot about this whole process. So ZK on Solana at a quick glance here. We have a lot of primitives already available, and a lot of companies and individual projects building a lot of different different ways of incorporating ZK into the stack. And there's a list of them down here. Feel free to look at them later. This talk, we're going to be talking about confidential transfers, which is a particular protocol on top of our standard token program, which exists on Solana. So unlike on EVM chains, which I imagine most of you are more familiar with, on Solana you have standard token program that anyone can use in order to issue and manage their token. So you don't write your own smart contract in order to issue a token on Solana. Instead, you just reuse this one token program, and then you can get everything out of the box that it has, including confidential transfers. And so a lot of companies that we talk to want to know, well, okay, great, I love the idea of a stablecoin. I love the idea of being able to send transactions around the world in a fraction of a second. The speed is amazing, the cost is amazing, but am I exposing my balance sheet? And the answer is basically yes, right? Everyone, if they're able to dox your addresses, you're able to also understand everything about the business flows of that company. And so a lot of companies are extremely interested in confidential transfers and what it can enable for them in their own B2B flows around the world. As far as full privacy, I do think that people do want it, but it's a spectrum, and many of the payment companies are happy with having the exposure of their addresses and the exposure of counterparties, but less so the exposure of the actual amounts. And so they're also used to a certain amount of privacy already in the payment network that they're used to, right? So on the right, we have what they're already used to, which is everything is basically hidden unless you're in this private little network or you're a corresponding bank or something. And so it's bad for what they want to be able to do. And that's what we're trying to solve here, right? So at a glance, what is this actually, what's this protocol, what's happening under the hood, what are people able to see, and how does this work? So we have individual token accounts that have encrypted balances using Twisted Elgamal in enabling FHE for these different transfers, and then different proofs that go along with it for when you're doing a transfer in order to actually make sure that you have integrity as well. So there's like the range proof, equality check, and validity. And then so on chain, you're able to basically just see a 0 unless you have a decryptable key in order to actually see the amount for yourself. So senders and receivers can decrypt their own amount. And then there's also an optional auditor key, which an issuer can choose to configure for their token account to be able to actually decrypt any transfer that happens. And this one's extremely important. Issuers need to understand what's actually happening with their token. They need to expose this information to regulators. You have to actually be able to provide this information if you're going to bring this to scale. So selective disclosure plus these different setup under the hood here, right? So fairly straightforward, nothing too complicated or crazy here, but it does solve the immediate needs for all of these companies. Not, going to be it's not going to also work with Quantum yet, but we have some plans as to how to potentially upgrade. But that doesn't really seem to matter to people, to be honest. Not yet. They don't know. Okay, so step by step, how does it work? So like I said, we have a token which is using this token program, which everyone is using. You don't write your own smart contracts again, right? You're able to just reuse the standard. And so you configure your specific token with this confidential transfers extension enabled. Then you're able to set up your auditor public key to be able to decrypt the individual transfers, which are also encrypted to that public key. And then you set also a privacy level for that extension. So you can either have it, of course, disabled, opt-in, meaning anyone can create their own keys to be able to participate in this private transfers world, or whitelisted, where you basically have to have the issuer approve you and let you into that network. And then there's also a required setting here. So you could also just have it where every single transfer must be encrypted, right? That's also a setting here. On-chain, the auditor public key is available, as well as the encrypted balances and everything else. You can see that on-chain. The issuer policy in all of this is actually something that is fixed at the time of issuance or at the time of creating the mint, but you can change these individual settings as you go forward. Okay, so then an individual, right now I am using this token. What do I do with it in order to actually get access to this? I create my own Elgamal key pair as well as an AES key in order to have an easily decryptable balance. I then publish this and create the token account on chain for myself. So now I have an account that exists on chain that is ready for a confidential balance. On chain, we can see the Elgamal pub key, and then I can take my public balance and deposit it into my my confidential balance, and be able to then move it from one public setting into the private setting. The reason it has to go this way is because you have to have the total supply, unless you're having the confidentiality required for the token, but most don't. You have to have the public supply visible, and then you go from that into the private balance. Okay, so then after it's deposited in here, I'm sort of skipping through a number of the individual things. Feel free to ask questions as I'm going through, of course, if you have questions on some of the lower level. Then you apply it, and this is because you need to be able to use that, use your private key in order to then apply it to your actual full balance. These are not UTXO based, this is account based, right? And so then you compress that down, or add it into your own encrypted balance, and then now it's ready and available for you to do any transfers with. So if we go to the transfer, you are submitting the 3 ciphertexts as well as the range proofs in order to actually do the transfer and put it on chain. Only the sender and receiver can decrypt and actually see the transfer, as well as the auditor, right? So, okay, so the primitives here, right? We have our grouped ciphertext 3 handles validity, which is making sure that everything is encrypted to the same scalar underneath. Then you have the quality of the ciphertext on either side, the sender and the receiver, and then we also have the range proof using bulletproofs under the hood in order to make sure that we're not cheating, right? And then after all of this is done, you can keep doing this transfer throughout the different folks on the confidential balance, and you can then transfer it back into the public side of things. And here on this side, we are using, oh, I didn't mention that there's the Pedersen commitment to open as well as the quality here. Great. This makes some sense. These are fairly basic things in the world today, but it is a way to keep things fast, cheap, and very simple. Okay, so some additional things that were added in here versus the original protocol include the AES key, which allows you to have just a very quick available balance that you can decrypt. The El-Gamal proof program is a separate Solana program that's available for anyone to use. As I mentioned on Solana, you don't usually write your own smart contracts. You reuse standards that exist on chain, which allows anyone to now access these different functionalities through the El-Gamal proof program and do their own protocols on top of it. This is all baked in for you now. The different primitives that we have here, we have the Pedersen commitments, which is actually hiding the amounts inside the ciphertext and proof witnesses. We have the twisted El-Gamal encryption, which is encrypting the balance and transfer amounts. The Sigma protocols in order to do the pub key validity, zero ciphertext inequality checks. The group multi-recipient validity, which I said is making sure that the encryptions all match. And then the bulletproof range proofs in order to actually do the proving the transactions are valid. And that's basically it. That's the whole setup here. We did have, this has been live for a couple of years, and then there was a bug that was discovered with, of course, Fiat Shamir, because that's usually what it is. And it has since gone through, I think, 4 more audits and a bunch of other things. But even that first version was audited 3 times. So it's difficult to catch, apparently. I don't know. But we have some of the amazing auditors in the room, so thank you for your help on fixing some of the problems. Okay. I don't think I need to go through this too much. It's basically what I had already gone through, but more of the proof workflow here. So on the left, we have what's done on the client side, the prover, right? We do have a WASM SDK, so you can do this in your browser as well, or in Rust in a backend if you would like. And then in the middle, we have the ZK El-Gamal proof program, which exists on chain, that is only verifying the individual proofs. It's not actually caring about the token, right? So this is a native primitive that exists. And then on the right, we have another token program, or we have another program on chain, which is the Token 2022 program, which is actually including this functionality into any token that wants to use this. So now that we have it, right, now that we actually have deployed this, how do we get people to use it? And that's actually probably the harder side to a degree, because there's a lot of companies that need to individually coordinate and adopt this as a standard. Not only do you have to have the issuers who want to use it, so the PayPals of the world, the SoFis, the Western Unions, right, all of these have said that they want to use this. You have to get them to then pressure the custodians or their issuer partners to actually implement this and figure out, how am I going to use this auditor key? What do I actually do with this? Do I want to have that power? Do I want to do like some threshold signature thing on it? Then there's the wallets. Then there's the exchanges. If they want to be in this, does this fit their compliance rules? I don't know. How do you do travel rule, right? Like all of these things that end up bubbling up from this desire here is a part that I think is going to take a little bit longer, but we do have some good conversations already going in order to get this to happen. Also, the transaction sizes, this will be solved in a couple months at this point, but right now, as I mentioned, the transactions are restricted to 1,024 bytes, and this whole like transfer construction is larger than that. And so right now it doesn't fit into one transaction, which means you have to actually stack 3 on top of each other. But in a few months here, or less than that even, we're going to be increasing the transaction size almost 4x, and so that's going to be fine across on Solana generally. And then there's also the composability, right? So how do we actually do more with this? How do we bring this into DeFi? How do we actually do trading on top of this? How do we make it so it's not just this isolated little like B2B trading world or B2B like payments world? And this last one, it's an open question if we actually need it, because there are, like I mentioned at the beginning of the talk, a lot of different projects that are already live that are doing a lot more with other schemes. And so maybe this ends up just being the institutional solution just for payments, and I don't know, we'll see. And then, like I mentioned, the auditor key, right? So this particular piece is complicated to handle. You are able to rotate the auditor key. However, previous transfers are encrypted to the previous auditor key. So you're not able to keep that one forward, or you can't have forward secrecy on it. If that leaks, it leaks, right? So how do you actually manage this? Do you want to do, as I said, like maybe you do an MPC scheme with it and you're able to rotate the shares, right? So there's an open problem here as to what's actually going to become a standard and how people are going to be doing that. There's also questions from the regulators. What are they going to want to do with this? Is this fine? Does this fit into the Genius Act? Do they need to fit it in the Genius Act? Do we need the DFS to look at this, right? Like there's this whole other compliance and regulatory aspect that also needs to be weighed in here. And then what is the process for selective disclosure? Do you need approval from the sender or something, or the parties involved? Do you not need to? Do you need a warrant to do that? Do you not need to? Because everything has been private, or everything has been transparent on chain, there haven't really been the cases where like you actually need to answer that for individuals when this is baked into the protocol, right? We've had plenty of other experiences where privacy was the only option, and the selective disclosure has never really been tested in like the court of law. At least not on the on-chain side. Okay, so I have a little demo here. Hopefully it works. It's a live demo, so you never know. But so the setup that I have, this is running against DevNet. This is already re-enabled on DevNet. I've already configured a token. I've already set up my account to be opt-in. The sender and the receiver are already there. And I've already minted assets to this. So hopefully it loads. Here we go. So you can see everything right now because I have all of the private keys loaded up on my computer. So I'm decrypting these values live. And you can see the ciphertext, or a shortened version of it, which is the amount. And then you also can see the auditor view as well here, right? And then also the events that the auditor has seen in the past. So I tested this once before. So we have a previous transfer and a previous application of that balance to the end user. And then on the right, we have the public view. Basically, you just have the ciphertext. You don't really see much else. So if I push R, theoretically, we'll have 3 transactions created and sent on chain to Solana's DevNet. And there's the proofs that it's creating it on chain to be executed, and it's done. It worked. Great. So we have $250,000 left in the sender. We have $250,000 pending for the recipient. And then the auditor can see that this transaction happened. And if I were to click this, it would go to our Explorer. I might as well. So you can see that the public Explorer has no idea what happened here. I pushed a fix to this yesterday, but I guess it hasn't rolled out to prod yet. But here it's integrating with, it's just to actually like decode what's happening here. But for now it just says unknown, but you can still see the program information here, the instruction data, and the ciphertext that is included here, right? So we have all this, and we have some of the logs that happened. Okay. Cool, so now I can apply the balance. And there we go. Now we have the 750,000 in the recipient as well here. So this is the scheme. that we have on Solana. I think that it works quite well, and we will find out if it ends up getting used, but we definitely have folks interested. It's really a UX thing that we have to figure out from here on out. How do we actually derive the keys? How do we want to have a standard there? Do we let people just pick whatever they want? We have some suggestions that we've been sending around to folks. So on top of this, we're expecting Treasury rebalance, B2B settlement, any of the larger payment flows to be using this. As I mentioned, Western Union is interested, PayPal is interested, a bunch of these companies have this baked into their token and ready to go. But on top of this, we can also do a lot more interesting things beyond just payments. We can have some other things around private trading or sealed bid auctions. Or I heard that there's actually a university that is considering using this to do encrypted governance and votes and be able to actually do their own voting system. And you can even do it in a scheme where professors can have more of a say than the individuals with more tokens than what an individual has. So this exists for anyone in the room if you guys wanted to try it out. It's not that complicated. And AI is actually pretty good at using this as well and building things on top. So things that I would love to see are, some of these things that I had mentioned around the private trading. How do we combine this with shielded pools or anything else? What other primitives do we need on Solana? We've had, I think, 6 talks about some check, so maybe we should do something there because it's fun. And how do we also combine this with other things to keep up with Solana's speed? So maybe we need TEs instead of FHE completely on everything, right? There's a lot of teams thinking about this, but how do we make sure that we're able to keep things fast and still try to have privacy as much as possible? Okay, that's the entire talk. I have no idea where I am on time, but if you guys have any questions, please shout them out.
Okay, any questions?
Do you feel like adding a backdoor to your protocol was an unnecessary concession to the American regulatory state?
By backdoor, do you mean selective disclosure?
The auditor keys that can disclose the values of all of the transfers.
So it is optional, right? You can easily create a token. You can wrap a token in your own program, in your own token that doesn't have that. Go ahead. We're not forcing it on anyone, but Solana is very practical and pragmatic in the sense that if you want this to scale, you're gonna need selective disclosure.
There was a similar design decision that we faced in Zcash when Gitter proposed kind of an auditing feature that I considered to be a backdoor. And that was also optional per token. It was associated with ZSAs, which haven't activated yet on Zcash. But I argued successfully that was the thin end of the wedge and that we should not include features like that. So just, as a counterpoint to what you said.
Sure. Yeah, it's an open argument, and that's why we have multiple chains doing multiple things, right? So we're able to hopefully push everyone forward. And as I said, take USDC and create your own fully private, non-audible version. Go ahead.
All right, more questions? If not, let's thank Ilan again.